This is lab 3, frequency response of a flexible beam, and this is group 8-7. So for this lab, we had to use this setup that was given to us, where we were looking at a rotary server that had a flexible beam, and that beam would shake and deflect, and then we used a combination of MATLAB and the Quanser server motor and its software to get these values in order to model the frequency response.
So the first thing we did for the experimental procedures was calibrate all of our tools. We did this by measuring the strain gauge voltage and deflection at 2 inches to -2 inches. Then by measuring that data and fitting it with a linear fit, we were able to calibrate the tools. So from there we measured the frequency responses of specific frequencies, and then we did the same tests, but we used random vibrations. Then we were able to fit them with various functions. So for the specific frequencies, we plotted 6 sets of frequencies that were given in the lab manual. As you can see, figure 2 is test 1 for the motor angle and deflection versus time.
For the random vibration tests, we ran 5 random tests. The data was then combined, and fast Fourier transformation was performed to calculate the graph as a amplitude ratio versus frequency in a semi-log scale. From this, we were able to determine a transfer function fit, and by doing this, we were able to figure out what frequencies established the amplitude ratio we were looking for. So overall, the sinusoidal forcing allowed us to measure the amplitude at a specific frequency, but with the random vibration test, we were able to gather data and be able to predict the deflection that would be caused by the angular velocity within a range from 1 to 100 radians per second. Thank you.